In grade 10, you solved, if you had this equation, 2x plus 3, okay, and then you had another line, y equals 5x, let's see here, minus 4. No, minus 3. Let's go that one. Okay? These are two different lines with two different slopes and two different y-intercepts. And in grade 10, you had to find out where they crossed. This is what a system of linear equations says, that if you have two equations, I'm going to label this one equation number 1 and this one equation number 2. If you have two equations with two variables, then you can solve for where those lines intersect, or you can solve for the values of x and y. How did you do that? You learned two different techniques. There was like the substitution technique and the elimination technique. Do you remember that? So the substitution technique looked like this. I have these two equations. I know that y equals 2x plus 3. So that means in my second equation, instead of writing y, I could write 2x plus 3 instead of writing y. If I did that, I could combine my like terms, move my 2x over to this side, which would give me 3x, add 3 to both sides, which would give me 6, and it would tell me x has to be 2. Once we find out x has to be 2, then you would need to find y. You could find y by plugging it into either one. What happens if I plug in 2 into the first equation? Y equals 2 times 2 plus 3. Y is equal to 7. If you plug 2 into the second equation, 5 times 2 minus 3 also equals 7. So these two lines intersect at the point 2, 7, and that would be the solution. The solution is x equals 2, y equals 7. Now in grade 10, you mainly did it with lines and found out where two lines intersected. Okay? Now we're going to get to our next question, where this idea is just in the middle of the question. It's considered that you know it like common sense, that whenever you have two equations with two things that you don't know, you can use substitution to solve for it. So let's see how that works out. Example number 3. The equation of the axis of symmetry of a graph is x equals 3. The graph passes through the points -1, 6, and 5, 0. We need to find the equation of this quadratic function. So first of all, we know that quadratic functions look like this. This is the standard form of the quadratic function. We have to put numbers in for a, for p, and for q so that all of these things work. One of them is easy to find first. Which letter? A, P, or Q? P. What does P have to be? Okay. You know, so find P first. Since the axis of symmetry is x equals 3, that means if I drew a picture of this, you know that your vertex is somewhere on this line x equals 3, which means inside of here, we know that P has to be 3. Okay? Now I'm going to write this with proper math language. So next, what we're going to do. So number one, first find P. Number two, we are going to plug in the points -1, 6, -1, -6, and 5 and 0 to get two equations with A and Q. If the point -1, -6 is on the graph, that means when we plug in -1 for x, y is -6. So if I plug in -6 for y, then I plug in -1 for x. Put that little -1 in brackets, squared plus q. If I simplify this equation, I'm going to have -6 equals 16a plus q. I can't solve that equation because I have two things I don't know. I don't know a and I don't know q. I'm going to call this equation A. I'm going to plug in 5, 0. That means when y is 0, x is 5. And simplifying this, 5 minus 3 is 2, 2 squared is 4. I get 4a plus q. I'm going to call that equation B. And it is at this point in grade 11 that they're expecting you to say, hey, that's just like solving systems of linear equations in grade 10. I know what to do. So everything you learned in your previous math classes comes back again, and you've got to use it when it comes up. Because right now, I have two equations, A and B, with two things I don't know. And that is a system of linear equations. Right? They're like y equals mx plus b, but instead of y and x, we're using a and q. That's dumb. Which letter do you think would be the easiest to get all by itself, A or Q? Q. Which one do you want to get Q by itself in, equation A or equation B? B? So if I get Q by itself, I would have to subtract 4A on both sides to get Q by itself. Are you okay with that being equation B rearranged? And so now I can go to equation A. -6 equals 16a, but instead of writing q, what am I going to write instead? -4a. So -6 is equal to 12a. Divide both sides by 12, and I get a is equal to -1/2. Once you've found A, you can now plug in -1/2 for A into either equation A or equation B to find Q. Which one would you like to use to find Q? You have to plug in -1/2 into equation A or equation B. You want to use B? If I use B, B says 0 is equal to 4, and instead of A, I'm going to write -1/2 plus Q. 4 times a -1/2 is -2 plus Q. To get Q by itself, add 2 to both sides. So then we can find both A and Q, using that idea from grade 10 of solving systems of equations. In order, I'm going to change the view here so we can see everything that we've done so far. We wanted to find the equation. So we needed numbers for A, for P, and for Q. We found P right away. You know that it has to be x minus 3 squared. Now we know A and Q as well. So we can say our final equation is y is equal to negative 1/2 bracket x minus 3 squared plus 2. Question number 9 for practice. That is a lot of work.